from Elko, Nevada. I hope that everyone can hear me loud and clear. I understand it's the first time you've done it this way, so there's always growing pains. Remember when PowerPoint projectors never synced up with laptops? Anyway, the title of the talk is a little different than what was in the flyer. That's because last night I pre-recorded the same talk for a New Gen Gold conference in Perth in a week. And it was an exploration case study talk. So I decided rather than do a different talk on successive nights, you get to hear that one. So the title is A Multi-Million Ounce Carlin Style Oxide Gold Deposit Hiding in Plain Sight. I'd like to acknowledge my co-author, Will Lepore. Will actually had a lot with putting this deposit story together, starting with an exhaustive compilation and a modeling exercise, followed by managing the project on the ground for a year until he moved up or on, depending on how you feel about it, to the corporate head office. So here we go. Cautionary notes, read them fast. They won't be up here for long. Just a caution that forward-looking statements are likely to be made during this talk. I'd like to introduce the rest of the technical team. These are the people that have a hand directly in the technical success of this project. I truly believe that teamwork makes the dream work. So on the left, these are corporate head office people who do make frequent trips to the project. And on the right are the people on the ground. Randy Hennick is the on-site project manager. And a whole host of other geologists that are the ones in and day out that make this project happen. You'll notice that quite a few of us are ex-Frontier Gold people. As was mentioned, we developed the Long Canyon story and sold our company to Newmont in 2011, and it's in operation now. So by way of introduction, the asset here that we're after is a past producing bulk tonnage run-of-mine heap leach operation. I think I can convince you that this is a Carlin style deposit, even though it's located about 300 kilometers from the Carlin Trend itself. The mine produced 435,000 ounces of gold from 8 small, shallow, some might say scabby, widely scattered pits. It is a very large property, and it has a huge legacy data set with over 1,800 shallow drill holes and tens of thousands of surface samples and blast hole samples. And this is the best kind of leverage, using other people's money to drill all those holes. So why we liked it, there was lots of gold remaining in the ground. There was over 1,400 historic drill holes with unmined intercepts, had simple metallurgy, and proof of concept. It was economic even during a period of very low gold prices in the 1990s. There was evidence for the presence of a very large gold system, including a huge soil anomaly that covered multiple square kilometers, and it's located in a great jurisdiction. So a little bit of context here. This slide was mainly for the people in Australia. I'm sure you're all familiar with Carlin deposits, but just briefly, Carlin type deposits are located along the early Paleozoic rifted continental margin of North America. Most of the host rocks are Ordovician and Devonian. Slope face these rocks, and this green line right on here, I hope you can see my cursor, is the Devonian platform edge as defined by Harry Cook, famous stratigrapher. I'm sure most of you know him or have worked with him in the past. The large deposits, of course, are concentrated in trends. The big ones are the Carlin Trend and the Cortez Trend. The largest deposits are in these green and sort of teal colored rocks in the slope facies here. Alteration types include silicification or jasperoid, clay, mostly illite, and decalcification. Gold is hosted in the lattice of arsenical pyrite rims on pyrite grains. And there's a geochemical association with arsenic, antimony, thallium, and mercury. They are temporarily associated with Eocene and younger volcanic rocks. And this is tectonically part of a slab rollback event that started in the north and progressed to the south, along with the age of the deposits. Most of the big ones are about, say, 37, 38 million years old. But there's lots of similar looking deposits on the Paleozoic shelf and platform inboard of this green line. And those are shown on here. And they have a wider range of host rock ages from Cambrian to Permian, and even one down here, Goldstrike, which is another of our properties that is hosted in Eocene rock. And similar alteration, similar geochemical fingerprint, and you hear these called Carlin style or even Carlin-like deposits. The black pine is located way up here in the corner, about 300 kilometers to the northeast of the Carlin Trend. Also, by way of context, what we're talking about here is a deposit that is likely to become a bulk mineable run-of-mine heap leach operation. And here's some operating mines in Nevada. The average resource and reserve grade is right around 0.5 gram per ton gold. That's because the cutoff grade is very low and it drives down the average grade. Some of these cutoff grades here are rather breathtakingly low, but these are some of the lowest cost producers in the world, so it works. Black pine is located right on the Idaho-Utah border. The access is excellent. If you came from Denver, it'd be about an hour flight to Salt Lake City, rent a car, drive up I-84, and it's about 2 hours to the property. So this is a large property. The claims are shown on here. This is a block of state mineral rights we're going after. These are BLM areas that are closed to mineral entry, but there are other ways of acquiring them. The project access is excellent, great roads, I-84 going by. There's hydroelectric power right to the property boundary. Nice clean green hydroelectric that should be good for burnishing our environmental creds. The place was burned in 2007, so there's no timber values. There's no water in the pits or any of the drill holes. Some of those are drilled down to 500 meters deep. There's no fish-bearing streams. There is groundwater in this basin that is off to the east, but there's no groundwater where we don't want it. It was obviously previously mined and reclaimed, and so people have been looking at that disturbed view shape for up to 30 years. So we think this is a perfect storm for a relatively easy permitting path. Looking at the geology, this is the Black Pine Mountains. Here's the property boundary, and these are the outlines of the historic pits. We have a lower plate exposed in the middle of the range here at low elevations, the Devonian Mississippian platform and foreland basin strata. This is overlain by a middle plate in green, purple, and blue here of Pennsylvanian ochre formation. Consists of limestone, dolomite, calcareous siltstone, calcareous sandstone, etc. It's in bold here because that is the gold host. It's overlain by an upper plate here of Permian ochre formation, non-calcareous for the most part, sandstone and siltstone. So 3 plates. All of them were thrust imbricated during the late Cretaceous severe orogeny. Since Chuck Thorman is here, I should mention that some of that deformation might be Jurassic in age and part of the Alco-orogeny, but we haven't been able to date it. This was followed by episodic top to the east, low angle listric normal faulting episodically from Eocene through, say, early Miocene. And this reactivated old thrust faults. Finally, there was high angle. Oh, that's in bold too, because that's when we think the timing of the gold mineralization was. Finally, there was high angle normal faulting, Pliocene to recent, the classic basin and range faults. Here's a good one right along the edge of the range here. Zooming in on the property itself, again, there's 3 structural plates, lower plate, middle plate, and upper plate. The red circle here is where all the historic pits are located. And I wanted to point out this range front fault here again. This down drops the east side of the fault such that we have upper plate rocks exposed on surface. Everything kind of dips away from this central area here, dipping to the north, to the south, and to the east. The stratigraphy here is really complicated, partly due to a lot of structural disruption, and also during the Permian, Pennsylvania, periodic drying out of the platform and basin, and addition of siliciclastic material from the craton to the east. So we've got things sort of simple in here. It all looks good. When you look over at the actual rock types we're talking about, it's mainly a matter of degrees. So for example, this purple unit here, it has a preponderance of massive dolomite and limestone, so it's a little more purple, but we do the best we can with what we've got. This lower plate here is sort of a melange unit, separating it from the middle plate, and we think that's because there might be up to 20 kilometers of offset on that fault related to the Albion Raft River core complex, which is right next door. So anyway, last thing on here, we have these gold host stars on here. A lot of stars is a good gold host, and it mainly has to do with how much calcareous siltstone is in the rock. So this POLC unit has a lot of calcareous siltstone in it, and it's the best host on the property. But for example, these non-reactive, non-calcareous sandstones are not a good host rock. So now we're going to put that together with the structural geology. The late Cretaceous severe fold and thrust belt predated mineralization, and it's the architecture on which the gold system was superimposed. So in this view of a pit wall here, we have phase 1 thrust faults and these beautiful recumbent faults here. This fault probably started life as a thrust fault, but ended as a normal fault. This is upper plate, this is middle plate. Then we also see some open upright faults that are related to smaller thrust faults as well. This is not as common. Typically you see something that looks like this. I just look at this and I think about the first operators that drilled RC holes in here and didn't have the benefit of those pit walls, then trying to figure out the geology from RC drilling. Next, we move on to Cenozoic extension. Early extension at Black Pine was on low angle faults. Some of it was relatively ductile and reactivates thrust faults. Gold, if it follows the path of the Carlin trend, is spatially associated with listric faults that are about 37 to 40 million years old. About 20 million years ago, we had unriffing of the Raft River metamorphic core complex located just to the west. This extension would postdate the mineralization. Last, we have the Pliocene to recent basin and range extension that is clearly post-mineral. So in this pit wall, we can see some ductile down to the east faults or shears. That's illustrated here. Then we have a low angle fault separating our POLB unit from POLC. Then we have a fault that's post-mineral, very brittle fabric that offsets that contact. If we look over here in the bottom left, we can see a 3D model with the drill assays. Then you can see that gold is almost entirely restricted to this POLC unit, which has a lot of brittle deformation and a lot of calcareous siltstone in it. So gold mineralization as black pint is really similar to oxidized Carlin type deposits throughout the Great Basin, hosted in Paleozoic carbonate rocks, spatial association of gold with brittle structures. Alteration is typical Carlin decalcification, silicification, and clay alteration. Also, gold is associated with elevated arsenic, antimony, thallium, and mercury. So we have the Carlin fingerprint. It's all pervasively oxidized. So rather than having gold associated with pyrite, it's associated with iron oxides. Gold is primarily submicron, but we do see it as 2 to 5 micron grains. This is probably a result of the oxidation process. So these rocks don't look too exciting, especially the first couple that are kind of brecciated, decalcified siltstone, but they certainly do the job. And then we have some beautiful breccias in here as well. So when you put all that stuff together, you end up with kind of a tectonostratigraphic model. You have good rock types and poor rock types, and each of those reacts to deformation differently. So for example, this POLD unit, massive limestone and dolostone, there's relatively little deformation. It's not very porous or permeable, but you have these weak rocks sitting right on top, so deformation is focused there. So again, the best rocks have a lot of calcareous siltstone and brittle deformation. And you see that in these two pictures. The one on the right, that POLB unit is a poor host rock, and it's got a lot of ductile structures in it, but the POLC sitting under it is stratigraphically a good host rock, and it's very brittly deformed. You see the same relationship on the left. So starting to put it together and move into the case history part of it. If you are approaching the property on the access road from the east looking due west, this is what you're going to see. The bottom here, you can see the little pits that are scattered at various elevations on the east side of the mountain range. And then on the upper part, this is a cartoon schematic section that shows at the base, the shutdown rocks, the lower plate. At the top, cover rocks, the upper plate. It's about 400 meters thick with thrust integrated package of carbonate rocks. And we see gold going all the way from the very top to the bottom. It's about anywhere from 100 to say over 500 meters thick, probably averages 300 or 400 meters thick. And so that's a good vertical section to get to drill. And then we have about 4 kilometers north to south and about 3 kilometers into this section. So it's a really big sandbox to play in. So the early part of the discovery history here in the late 1800s and early 1900s, there was small scale mining of silver and base metals and mercury, mostly around the periphery of the gold system. This is fairly typical of larger Carlin districts, and the people didn't recognize that there was gold there because it was so fine grained. In the 1950s, there was mining of about 100,000 tons from a small pit located right in the center of the gold system and a small heap leach operation. The 60s to the 80s were kind of the golden age of Carlin exploration throughout the shelf after the significance of the Carlin mine itself was made known and heap leach technology really accelerated. But it was really Miranda exploration who came in there in 1986 that they mapped the framework geology, which is an amazing piece of work. They drilled over 500 holes and to find outcropping oxide gold ore bodies and produced a feasibility study. But I guess the head office didn't think it was a Miranda-sized target. So they sold the property to Pegasus Gold in 1990. Pegasus mined the outcropping ore bodies. They drilled over 1,300 very shallow holes, and they didn't really add to the geologic story there. So it was a run-of-mine heap leach, produced 435,000 ounces from approximately 666,000 ounces, so about 65% recovered. we're later learning that the heap leach wasn't managed all that well. And so we think that we can do better there. The average life of mine head grade was about 0.63 grams per ton. They sequentially mined 8 ore bodies. Those are shown on this oblique view to the west of the various pits. And you can see how they mined them, starting with Tallman pit and ending with the Tallman extension pit. It looked like they mined until their strip ratio got too big, and then they just moved on to the next one. So they didn't actually mine anything out completely. Well, Pegasus declared bankruptcy in 1997 on the back of a failed operation in Australia. They fled in the dark of night, and the U.S. Forest Service seized their reclamation bond and reclaimed the property. So that brings us to Discovery History Part 2. From 1998 to 2009, the claims lapsed. It was open ground, which I'll show you in a couple of slides why I think that's amazing. In 2009, Western Pacific came in and staked the open ground. They were able to recover data for about a third of the drill holes, basically everything up till the sale of the property to Pegasus. In 2011 and 2012, Western drilled 35 holes, primarily within and around the old pits. But that was a really bad time to have a company in a property because, as you know, the gold price was going off a cliff then, and they encountered market headwinds. About that time, I visited Black Pine, and I could see this shallow dipping fault fabric and similar stratigraphy extending between all of the pits, even though they were at all different elevations. And so I thought immediately that probably controlled the gold, and that could extend between all the pits as well. But it wasn't until 2016 that Liberty Gold actually acquired the property. We paid $800,000 in cash, 100,000 shares in a small NSR. Hopefully by the end of this talk, I can convince you that that was a really good deal. So within a couple weeks of buying the property, we were able to recover virtually all of the historic exploration and mining data and all the Pegasus data. And that embarked on an 18-month compilation exercise, 3D modeling, and very important, permitting a huge area for exploration. So in a couple years after we got the compilation done and the permit, we drilled holes in 2019 and 2020, discovering new mineralization below and adjacent to the old pits. And just a few months ago, we came out with a resource estimate. So to show you a couple of these data sets, there's several generations of surface, soil, and rock sampling. This is all the soil sampling compiled in one place here. And I'll just call your attention to the scale bar, that's 1,000 meters, and the red dots, which are 100 ppb or better. So this is an enormous area here, and it basically takes in all of the outcropping middle plate. So you can see why I was amazed that this could have sat open for 10 years in plain sight. Another database, here's project drilling. There's 775 holes drilled up to the sale of property to Pegasus, and about 1,100 holes drilled by Pegasus during the mining operation. The colors are black on here. Pegasus really focused on reserve drilling, so that's why it's so dense in all these pits. So Liberty Gold colors up to today, more or less, are shown in yellow, and you can see that they're concentrated right here. And the reason is we could see outcropping higher grade mineralization in the high wall of this B pit, in the high wall of this A pit, and in this area over here that was defined but never mined, called the A pit. So this area is what I'm going to show you in the next slide. And we are looking to the east here at the area between the B pit, the A pit, and the A basin area, big ridge here. And we thought the rocks looked really similar in all three places, and the grades were good. So the thinking was that this is an enormous area between these three things. And if things all came together under this ridge, we could have a really large gold deposit. So, excuse me, we started drilling there. We came up with actually 3 zones. The first one was D1, then D2, and then D3. And what happened is they all coalesced into one big zone. So the next slide I'm going to show you is a section going through about like this. And we're looking to the northeast here. So the basic premise was correct, but the details were a little bit more complicated. So this shows pre-mining drilling, and you can see some shallow ore bodies defined here. Everything purple is over 1 gram, and the very shallow nature of the holes. Then this is post-mining drilling, the B pits in the A pit, and you can see they didn't entirely mine them out. And there was lots of indications that some of this higher grade mineralization probably extended to depth. The bottom image is after we were done drilling here, or after the 2020 drill season, and you can see that this zone here extended down and all the way over to the A pit. We discovered another zone of mineralization underneath it, and there's a lot of low-grade mineralization between these higher grade zones. Both this zone here is floored by a listric normal fault, and this zone is as well. They both soil into this lower plate contact. Showing you some of the drill results. The database was organized by grade times thickness. Yellow are 2019 drilling, orange is 2020 drilling, and you can see some really nice thicknesses in grades. And when you consider that grades from say 2 grams up to over 4 grams are roughly 10 times what is getting mined in these run-of-mine heap leach operations right now, yeah, I think these are really actionable results. So we put it all together this year and released a resource estimate. The resource contains about 1.715 million ounces indicated at an average grade at 0.51, and a much smaller inferred resource. And then if we look at higher grade subsets of the resource, so for example, using a cutoff grade of 0.5, we end up with still over 1 million ounces of indicated at an average grade just over 1 gram. And this is really what's going to drive the economics of the deposit. If we look at this in terms of geographic distribution, the largest area is our discovery zone. This is where we did most of our drilling, and that contains about 74% of the resource at a higher average grade. And you'll see it's almost all indicated because that's where we spend our time drilling. These peripheral zones, many which are around historic pits, is mostly historical drilling, and that's what we're focusing on now, is trying to expand. Like, can we bridge the gap between these little pits here or in this zone back here? So it's important in the rest of the talk to just note that there are 2 small pits in this range front zone here, and this zone right here was very shallow condemnation drilling because that heap leach pad, the historic heap leach pad, is located right here. So a couple cross sections here. This is A to A prime, looking to the northwest through the discovery zone, and you'll see high grade lenses that are surrounded by lower grade material here. And you can see that we modeled it so that it was very tight to structures and stratigraphy, and that there's 2 main zones, both floored by listric normal faults. Well, we started doing engineering work pursuant to a PEA and realized that we really needed to look at a lower cutoff grade. So here I put the 0.1 to 0.2 blocks on here in yellow. They're not resource, just shown for illustrative purposes, but this is really the direction that we're moving with this. And you can see when we do, virtually this whole zone is mineralized, and your strip ratio goes way down. It's pretty impressive considering this is about 300 meters thick here. Cross section B to B prime is looking here, looking to the southwest, and we're going down the discovery zone to the southeast. Here's the main area of mineralization, the historic B pit and the historic Tommen pit. Again, we see this high grade core surrounded by lower grade material. And again, when we put the 0.1 to 0.2 grade blocks on there, it basically fills up this whole area here. We are doing infill drilling now to upgrade inferred blocks to indicated, and also testing some of these peripheral areas to see if we can find higher grade mineralization that would pull those areas into the pit. Got to say something about metallurgy, because if you can't get it out of the rock, it's not going to work. So we've done 3 phases of metallurgy so far, from bulk samples from historic pit floors and variability contests from core holes. And we just released a phase 3 last week. So we're getting quite a lot of samples from a wide geographical area here. All 3 phases resulted in similar results with about an 80% weighted average gold recovery. And it also confirms historic metallurgical testing by Noranda that was done at the same lab using the same techniques, so we can use that data as well. Well, the upshot of all this, and this is showing our phase 3 results here, is that we see very rapid gold extraction with over 80% of the gold extracted within 10 days in these column tests. That's fairly typical of Carlin oxide deposits, but it's always nice to see. As well, head grade and gold extraction are well correlated. That's shown on this lower chart here. If we assume that we're going to end up with, say, about a 0.5 average grade, then we're looking at, say, 75% recovery. The percent extraction is not sensitive at all to particle size, so we can take these same results and project them out to run of mine, and we hardly lose any recovery. As well, the data, along with load permeability testing, suggests that a simple run of mine heap leach process is viable here. Excuse me. Okay, so we have a 2 million ounce deposit. It has good metallurgy. We're working on the engineering part of it, but how big is this deposit going to get? So this is all of the drilling on the property and the drill assays. And we can say that there's large areas of exposed middle plate with good soil anomalies that are still untested or have not been tested below 100 meters. There's very little drilling through these upper plate cover rocks on all sides, and very little drill testing to the southeast of this range front fault. There's large gaps in the gold system. So for example, here's a section line, 7.5 kilometers long. Here it is down here. And you can see 2 large gaps in here. Focusing on this one, you can see in the well-drilled main zone, things come down. It's almost like a dip slope, and then it stops right at that range front fault. And so you have to ask yourself, is that because of a lack of gold or because of a lack of drilling? And we went into this area wondering if right here and going east, if this could be the faulted off other half of the Black Pine gold system just under shallow cover. There was one area here where they did drill some upper plate rocks that had mineralization in it, but again, the drilling is very shallow. So we did 5 holes from one site as an initial test. And this inset map, this little star here, shows where we drilled them from. We wondered whether the main fault coming off the discovery zone could come through here, and it seemed like a good place to drill. So the results were really stellar. Here's 3 holes on a section. This is what it looks like on an inset. 356 returned 86.9 meters of 0.91 grams, followed by 21.3 meters of 2.03 grams. This is actually one of the best holes on the property. You can see the very shallow drilling in the range-front area over here. We think that in this area, we see a phase change in the upper plate from non-calcareous into calcareous rocks that suddenly makes them a halfway decent host for gold mineralization. So as you can imagine, we are very busy over here. We've got about 30 or 40 holes in the lab pending results from this area right in here. We're hoping that that all coalesces into a deposit that rivals the discovery zone in size. And remember, 74% of the resources in that area. So to kind of summarize the exploration case history, if you will, mostly the modern part of it, the framework geology and the surface ore bodies were defined by Noranda. It was later mined by Pegasus. But after that, there was 10 years where Black Pine basically hid in plain sight. I think a lot of that had to do with this dogma-driven exploration for Carlin deposits where you had to be on the slope and you had to be on these trends. So things got neglected out to the east. The first company, West Pacific, they recognized the potential, but they weren't able to capitalize on the opportunity. And Liberty were really the right company, being well capitalized with some significant in-house expertise and off-trend Carlin systems, and in Great Basin geology, and experts in compilation and modeling. And we were there at the right time toward the bottom of the market. The asset met all of our hurdles. It was data rich, there was gold in the ground, the size potential, good jurisdiction, simple metallurgy, and we were able to pay the right price for it. So now Black Pine is a multi-million ounce resource, and I think it's going to get a lot bigger. So our future work, we're doing infill drilling for resource conversion. We're doing resource drilling in that range front area. We're doing step out drilling around the existing pits, geotechnical drilling for making pits on it. We're going to put out a revised resource estimate that reflects a lower cutoff grade and these newly discovered zones. That'll probably be early next year. We're working on a preliminary economic assessment. We're just about finished procuring process water for an operation. We're starting ESG activities. And of course, you can't have enough metallurgy. You can never stop operating. So all this hopefully will lead to a pre-feasibility decision relatively soon. That's the end of my talk. Thank you very much.